Hi everyone, this is a little mini lecture just to catch up from the freeze day. So we're going to go with the quadratic formula and then the discriminates. So quadratic formula. If ax squared plus bx plus c equals 0, then if we use completing the square, we get that x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Make sure that looks like an AC there. And also, I like to slap in some parentheses right there just to make sure that we're all clear on that the AC, that's the product. So it's b squared minus the product of 4 times a times c. Just because I've had students tell me that that part was confusing. So I just want to be crystal clear about that. So if we do the next two examples, then we have, okay, if I want to know how to solve 9x squared plus 3x minus 2, well, because of this 9 right here, it makes completing the square kind of annoying, or at least I don't like completing the square when there's a non-1 value there. So that's where quadratic formula comes in. It's really nice because we can just plug and chug. So this says that A is 9, B is 3, and C is negative 2. So then we just plug it in. So this from the formula says that x equals negative 3 plus or minus the square root of 3 squared minus 4 times 9 times negative 2. Oops, extend my root there. And then over 2 times 9. And then we just simplify. So that's negative 3 plus or minus the square root of 9. And then a negative and a negative give us the positive. Oh, wrong color. Where is my, there it is. I think it's this one. There we go. Our 9 plus, let's see. Well, 4 times 2 is 8 times 9 is 72. All over 2 times 9 is 18. So then we just keep going. So negative, ooh, I should have written smaller. Okay, 9 plus 72 is, oh, what do you know? 81 over 18, right? So then that is the square root of 81 is 9. So it's negative 3 plus or minus 9 over 18. And then 3, 9, and 18, of course, all have a 3 in common, so we're going to reduce that down. Let's see. Oh, that's like a white. I don't like that. Let's try this. I don't know. What color should we do? This, I don't know. Cool, kind of brownish, shimmery one. That's fun. Okay, so that's a 1, that's a 6, and that's a 3. Right? 3 goes into 3 once, 3 goes into 9 3 times, and 3 goes into 18 6 times. So back to my blue. We have negative 1 plus or minus 3 over 6, which then gives us negative 1 plus 3 over 6 and negative 1 minus 3 over 6, which is, of course, let's see, I'm running out of room. Let's see, 2, 6, 3 minus 1 is 2, 6, so that is then 1/3. And then this is negative 4, 6, which is negative 2/3. And voila, there's our answer. Not too shabby. I do want you to pause the video and try B on your own, see how it goes, and then unpause when you're ready to come back. Okay, so let me get a line over here. See if I can squeeze all this in. Okay. So I like to get all my ducks in a row before I start. And then here, notice the C is actually 2 because I need to move that over because we like quadratics that equal to what? 0. Yeah, 0. Okay, so now I'm going to pop into my formula. So that is right here. Right, there's the formula. I'll change colors. Let's see. Let's go with, yeah, let's try this. Shimmery brown. Shimmery brown. So x equals -1 plus or minus the square root of 1 squared minus 4 times a, which is 1, times c, which is 2, and then all over 2a, which is 1. All right, now we just simplify. So it's -1 plus or minus the square root of 1 minus 8 all over 2, which is -1 plus or minus the square root of -7 all over 2. Sorry, that looks like a crazy 7. Plus or minus the square root of -7 all over 2. There we go. Much better. Much prettier. Okay. So that is now a complex number, right? Because I have -1 plus or minus I root 7 all over 2. And that's it. Well, actually, that's not it. We would want it in how many parts? 2 parts. So -1/2 plus, let's say, root 7 over 2i, and then -1/2 minus root 7 over 2i. And there we go. Ta-da! Perfect. Okay, actually, I don't like that pink over there. Sorry. I'll box it in. Whoops. Gosh. Feel like I just erased something. I forgot. There's the negative. There we go. So I like quadratic formula. It's tried and true. Like, unless you just kind of human error it, you can't really go. There's not a whole lot you can go wrong with it. Okay, so now the discriminant. What the heck is this thing? So the discriminant is the part underneath the square root in the quadratic. So that is the b squared minus 4ac. This is the discriminant. So who cares? What's it about a discriminant? Well, sometimes if I don't want to know an actual value, I just need to know what kind, type, or how many solutions we're going to get. This is where the discriminant comes into play. So if I have, let's go green. So if I have a positive, I was going to say under the square root, but that's implied. So if I'm positive, then we have 2 real solutions. If I am, I'll pop down here, negative, then we have 2 imaginary solutions. Also, some people say /0 real. No real. Okay. If I have 0 as the solution, then we have 1 real solution. Let's see. Well, I guess there's 2 positive types. You can have positive with 2 real and rational, and then 2 positive with real and irrational. Let me pop this down here then. So 0, 1 real solution. So I can have 2 real rational. And if I have positive second, I can have 2 real irrational. Basically, long story short, rational means that you get rid of the square root. Silly. Irrational solutions basically mean you have a square root left over in the answer. Okay. Irrationals, like it's a non-repeating decimal, right? Like pi, the number e, square root 2, square root 7, right? So above that is an irrational number. Well, I know it's imaginary, but like root 7 is irrational. Pretend like no I. 1/2, that is real rational because I can write it as a fraction. Okay, so the concrete examples. Determine the discriminant and then state how many solutions there are and the nature of the solutions. Do not solve. So again, I don't care what the actual solution is for ABC. I just care like how many solutions, what kind of solution will we have, essentially. So here, the discriminant, remember, is the b squared minus 4ac. But again, remember, you want to subtract the product of 4ac from b squared. So before we begin, I like all my ducks in a row. So this is x squared plus 4x plus 7 equaling 0, right? Because we love when quadratics are set to 0. Just makes our hearts so happy. So now we know for sure that A is 1, B is 4, and C is actually positive 7. So then my discriminant would be 4 squared minus 4 times 1 times 7. So then that is 16 minus what? 28, which is a negative number. A negative 8, if my math is mathin'. So here we would have 2 imaginary solutions or no real solutions. Again, I don't care what x equals. I'm just curious, like what and how many solutions are we going to get? Okay, so let's switch over now. Let's say, so we're set how we like it. Our ABC, sorry, I forget, like you obviously can't see what I'm pointing at. I got to get used to that. So my A is 2, B is -9, and then C is 7. So I would like it if you pause the video and try this on your own. Remember, you're just doing the discriminant. All right, so this is -9 quantity squared minus 4 times 2 times 7. So this is the positive 81 minus, let's see, 4 times 2 is 8 times 7 is 56. So it's a positive number. So let's see, mental math, 11 minus 6 is 5. 8 becomes 7 minus 5 is 2. Oh, that's 25. Remember, I'm going to go to my rainbow, that really this is the square root of 25, which is 5, right? So then the answer here would be 2 real rational solutions. Because we get rid of the square root. No more, because we just have 5. All right, and then C. Where are we? What color do I want to do? I do like this hot pink color. All right, so I want you to, again, pause the video and try C, and then play when you're ready. So it's said how we like it, 9x squared plus 30 plus 25 equals 0. So then we know 9 is A, 30 is B, and C equals 25. Sorry, I don't know why I wrote 30 equals B, not the other way around. Forgive me. Okay, and then, so 30 squared minus 4AC C is equal to 30 squared. Let's see. So 3 times 3 is 9. Add 2 zeros behind it. And then 4 times 25 is 100 times 9 is also 900. So what is that? 0. Yeah, I can do that in my head. So again, this would be a real rational because we get rid of the square root, but it's one real rational solution. Because essentially, if we bring in the whole kit and caboodle, the quadratic equation, right? Negative b plus or minus the square root of, well, we know that's 0 over 2a. Because from the discriminant, we know that this part right here is 0. Whoop. We know that's nice kind of lavender color. It's just negative b over 2a is what x would equal in C's case. Kind of fun. So again, we get just one real rational solution. Fun. Remember, rational means we got rid of the square root. Irrational means we would have had a square root left in our answer. Okay, we're almost done. One little thing. So a formula for the normal systolic blood pressure for a man aged A is measured in mmHg is given as P equaling 0.006 cap A squared minus 0.02 cap A plus 120. Find the age of the nearest year of a man whose normal blood pressure measures 125. I don't even know what mmHg is. I'm sure some of y'all do, and you're shouting at your screen right now. So forgive me. I know it's systolic blood pressure. But anyways, so what are we looking for? So if we're told we know that the blood pressure is the 125, does that go in for A or P? That goes in good for P because P, the systolic blood pressure, so is here in the age A. So we're trying to find the age. Here's my pink. Find the age. So we are trying to find A. All right. So 125 equals 0.006 cap A squared minus 0.02A plus 120. This is a quadratic, and what do we love quadratics at equal to? 0. Good. So we're going to subtract the 125 over. So 0 equals 0.006 cap A squared minus 0.02 cap A minus 5. Now, we're just going to practice using the quadratic formula because honestly, to factor this, no thanks. To complete the square with this, absolutely not. Blah, no. So we will do quadratic. So A is equal to 0.006. B is equal to negative 0.02. And C is negative 5. So we have X, actually, excuse me, cap A. Cap A is equal to 0.02 because it's a double negative, plus or minus the square root of 0.02 negative quantity squared minus 4 times A, which is 0.006, times C, which is negative 5, whoop, all over 2A. So 2 times 0.006. Okay, and this is where, let's see if I can go fancy. Hang on, hard hold, kick over there, please. Aha. So depending if you have a fancy schmancy calculator, let's see if I can get this to work. Alpha fraction, yeah, 1. There we go. Okay, so 0.02 let's just say plus the square root second x squared of 0.02 squared. We don't really need to worry about the negative because the negative times the negative is the positive. And then minus parenthesis 4 times the 0.006 times, now use your negative button. So use that negative button down there, right in the bottom right to the left of the enter button. -5, close parenthesis. Then I'm going to drop down to the denominator, 2 times 0.006. I'm just looking to double check I got all of my things in there appropriately. It looks good. Enter. There it is. Perfect. So this is 30.58. And then we'll just double check to make sure, right? Because this is an age. So is it okay if I get a negative number, or would it even make sense if I got like 0? No, right? A tiny, tiny baby probably would not have that high blood pressure. Systolic blood pressure. I can't speak. Sorry. Forgive me. Anyways, okay. So rather than type all of this again, I'm just going to do second enter, and then that brings up everything that you just input. So now I can delete that out and type in the negative, enter. Yes, and that one doesn't make any sense, right? That's the negative 27.25 with rounding. And again, that makes no sense because we're talking about age. So here, let me make this big again. For the systolic blood pressure of 125 units, sorry, I don't remember what that is right now, about 30.5 years of age. All right, that's the little short video. I hope you enjoyed it.